Specifically in your NCERT also they have mentioned the types along with the example. You have to go through with that. It is very much important for your board exam as well as for any competitive exams. There are 4 important colligative properties will be there. One is relative lowering of vapor pressure, depression in freezing point, elevation in boiling point and osmotic pressure. Sometimes delta TB values can be directly given. If they have given the 2 temperature, keep that in a point, you have to find out the delta T. That is the final minus initial. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to do with the revision part for the unit 2, that is solutions. Okay, before going to start with this unit, let us see what we are going to discuss in detail in this solution chapter. Okay, so in this chapter, we are going to discuss with the liquid solution and their formation. So it is very much important to understand, so what are liquids and what are the types of liquids will be there based upon the formation, and how does this liquids and their colligative properties will be learned. It is very important from this unit. Okay, there will be followed by studying the properties of the solutions like vapor pressure, colligative property, and we will begin to learn with the types of solutions and more importantly how to express the concentration of the solution with a different unit. We are going to understand with this unit. Okay, remember we are going to understand the special characters such as vapor pressure, colligative property, and what are all the types of solution based upon the formation, how to express the concentration of the solution with the different units. It's very important from this unit. Thereafter, we are going to study the Henry's law, Rolle's law, then distinguishes between the ideal and the real gases, how does real gases which deviates from the ideal behavior. Then along with this one we are going to discuss with the abnormality, that is very important, abnormal colligative property along with the association and dissociations of the solute. Okay. Let us see the weightage of this unit. From this unit, we can expect 9 marks, which is also one of the core unit for your second PUC. So, the question numbers are like this. From the part 1, we can expect the 2 questions in the 1 mark, that is question number 2 and 3. And similarly, in the part B, that is a question number 17, which carries the 2 marks. And in the part D, that is in physical chemistry, the question number 37, which mainly obtained from this unit. Okay, or mainly asked from this unit. And remember in the question number 37, definitely there will be numerical based upon the colligative property, and there will be a differences or a loss and all that can be asked, or with the last part of this unit, that is Van der factors, or they can ask the abnormality, okay, or the loss can be asked in the part D. Okay, we'll see with the 1 mark and 2 mark, 3 mark question, which is more frequently asked from this unit in the board exam. Okay, as I said, in this unit it is very much important to understand the types of solution and its formation and example for the each types. Okay, such kind of questions I have raised here. Give an example for gas solid solution. So gas solid solution, you have to give an example for that. So here the gas is nothing but hydrogen, the metal is nothing but palladium. Okay, it is a solid. So the solution of hydrogen and palladium is an example for gas in solid. Next, give an example for solid gas. So you cannot write this twisted and you cannot write it. So here the solid is nothing but a camphor and the gas is nitrogen. So camphor in nitrogen gas is an example for solid and gases. So specifically in your NCERT also they have mentioned the types along with the example. You have to go through with that. It is very much important for your board exam as well as for any competitive exams. Okay. Next, state Henry's law. We all know that Henry's law is also important from this unit. So at a constant temperature, the solubility of a gas in liquid is directly proportional to the partial pressure of the gas present above the solution. Okay, what does he state? At constant temperature, the solubility of a gas in liquid is directly proportional to the partial pressure which is exerted above the solution. Next, what happens to the molality of a solution when the temperature is increased? So the molality will be remain constant. So like this, the temperature effects can be also asked from this unit. Most importantly, we have to know about azeotropes. What are azeotropes? What are the types of azeotropes? Give an example for each types, they can ask with a twisted manner for your board exam. So azeotropes are nothing but a binary mixtures which are having same composition in the liquid and vapor state but boils at constant temperature. Such mixtures are said to be azeotropic mixtures. Next, what are types of solution? As I said, there are three types will be the hypotonic, hypertonic and isotonic. Okay, all the three types can be asked for your exam or any of this can be asked for your exam. You must know that what is hypertonic, iso and hypo. Okay, so what are hypertonic solution? The solution which having more osmotic pressure than another one is said to be hypertonic. Hypotonic is having less osmotic pressure than another cell. Okay, that is said to be hypotonic. Isotonic is having the same osmotic pressure between the cell. Okay, next, what is reverse osmosis? It is one of the important applications of the solutions which we use still in our daily life. That is, movement of solvent particle from a higher concentration to the lower concentration through semi-permeable membrane. When the pressure is applied greater than that of the osmotic pressure, it is said to be reverse osmosis. Or you can say that sometime to stop an osmosis, we will apply the pressure which is higher than that of the osmotic pressure, higher than that of the osmotic pressure. Such pressure which is enough to stop the osmosis, which is also known as what? Reverse osmosis also. Okay, what happens when RBCs are placed in 1% of sodium chloride solution? So, as I said, based upon these types, they have given a specific examples also. Sometimes they can ask a question like this directly. Sometimes they can take the example of the blood cells and they can raise the answer what is the kind of cells they have asked. Okay, so RBC will shrink. So, definitely it is hypertonic solution. Next, what is mean by Vanta factors? Or they can ask you with the Vanta factor value for association or with the dissociation. So, Vanta factor I is constant for the extent of association or dissociation of the solute in solvent, and it is always calculated with the formula I is equal to normal molar mass divided by abnormal molar mass. Okay. Next, we will discuss with a more interesting 2-mark question from this unit, that is, state Henry's law and write the mathematical form. So, when they ask you to write the statement along with the mathematical form, keep that point in your mind. You have to write a precise statement which has been given from the NCERT along with the mathematical form, and you have to explain the terms which is involved in the mathematical form. So, always write the precise statement. Okay. So, most of you lost the marks while writing in the statement because most of the teachers, they'll explain this Henry law with their own words, but own answers will not be considered for the examination. Please look at with the NCERT what is the precisely they have given the statement. You have to write the same statement for the board exam also. Okay. So, it can be stated like this. It states that at constant temperature, the solidity of a gas in liquid is directly proportional to the partial pressure of the gas, or you can say that the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in solution, and it is written as small p is equal to kH into x. kH is nothing but a Henry's constant, x is nothing but a mole fraction of a gas in solution, and p is a partial pressure of the gas. Okay. Next, state Rolle's law of a liquid solution and write its mathematical form. So, the Rolle's law states that the solution of a volatile liquids, in that the partial pressure of each component in the solution is directly proportional to the mole fraction. So, since you can see that it has stated for the liquid solution, it has related the partial pressure of the initial state and final state as P0 minus P divided by P0 into X. This is how partial pressure of the individual gases are related to mole fraction. Okay. Next, Write the differences between ideal and non-ideal solution. So this question can also be asked for your board exam as most frequently asked question. In this, let us see how to write differences between ideal and non-ideal gases. Remember, when we are talking about non-ideal gases, in non-ideal, again two types will be there, positive behavior from the Rolle's law or a negative deviation from the Rolle's law. So those deviation, what is the causes for the deviation, what is the specific example for that deviation can also be asked. Please go through with that examples from your textbook, and the question can also be raised from that point of view. Okay, so let us see the differences now. We all know that ideal gas is a gas, ideal solution is a solution which always obeys the Rolle's law, whereas a non-ideal solution which do not obey the Rolle's law, and the volume of mixing will be always equal to 0, then volume of mixing will be not equal to 0, and H mixing, that is enthalpy of mixing, will be a 0. Here a change in enthalpy or enthalpy of mixing will be not equal to 0, and intermolecular attractive forces will be A and AB type will be always AB types, but the intermolecular attractive forces between A and AB is not same as that of the AB when you consider. Okay. Next, we'll go with the isotropic mixture once again. We'll see with the types of isotropic mixture and how the question can be asked. So we know that isotropic mixtures are nothing but binary mixtures which are having same composition in the liquid and vapor state and balls at constant temperature. Example is 95% of ethanol or ethyl alcohol and 5% of water, then 68% of nitric acid with 32% of water. This is an example for the isotropic mixture, and the types are minimum isotropic mixtures and maximum isotropic mixtures. What does reverse osmosis? Mention the uses or mention any practical uses they can ask. Okay, as I said, to stop or osmosis, sometimes we will apply more pressure than the osmotic pressure. Such pressures are known as what? Reverse osmosis. So the process of reversing the direction of osmosis by applying the higher pressure, which is higher than the osmotic pressure, so that where they will apply this higher pressure, they'll apply the higher pressure on the higher concentration regions of the osmosis to stop the osmosis or to reverse the direction of osmosis. This is mainly used in desalination of seawater. Okay. Next, we'll go with the 3-mark question. We'll solve with the types of numerical that can be repeatedly asked from this unit. Remember, these numerical can be asked mainly from the colligative property. So there are 4 important colligative properties will be there. One is relative lowering of vapor pressure, depression in freezing point, elevation in boiling point, and osmotic pressure. From all this part, from all 4 colligative property, derivation will be not definitely asked, but numerical can be asked for the 3 marks. Okay, we'll solve some of the numerical now. So 5.8 grams of non-volatile solute was dissolved in 100 grams of carbon disulfide. The vapor pressure of the solution was found to be 190 mm of Hg. Calculate the molar mass of the solute given the vapor pressure of the pure carbon disulfide is 195 mm of Hg and molar mass of the carbon disulfide is 76 gram per mole. Okay, so you have to calculate what? Molar mass of the solute. In all this colligative property, you are going to find out the molar mass of the solute only. So I'll write this formula, that is M is equal to W1 into M1 divided by P naught minus P divided by P naught. Okay, into this is W2 into M1 divided by P naught minus P divided by P naught into W1. Okay, if you rearrange this equation, you will get W2 into M1 P naught divided by P naught minus P into W1. Now, we'll place the values for the W2, W1 and P naught and P. So we know that they have given 5.8 grams of non-volatile solute is dissolved in 100 grams of carbon disulfide. So the values which is very lower you can consider as W2 because it's solute. Okay, so I'll write W2 is nothing but how much? It is 5.8 which is dissolved in how much? It is dissolved in 100 gram. Okay, 100 gram. Then what is the molar mass of the carbon disulfide they have given? That is 76 gram per mole they have given. Then they have given the vapor pressure of the pure carbon disulfide, that is P naught value they have given, that is 195, and partial pressure is also they have given, that is found to be 190. Okay. Now please substitute the values. W2 is 5.8 into what is M1, 76 into what is P naught here, it is 195 divided by 195 minus 190 into what is W1, it is 100. Okay. If you first subtract these two values, then multiply these two, and then divide with 100 with the remaining values of these multiplication subtraction, you will get 5. 5 into 100, it's 500 only. So divided by with these value, you will get 171.91 gram per mole. 171.91 gram per mole. This is how, simple numerical we can solve and we can get 3 marks from the colligative property, especially from relative lowering of vapor pressure. If they ask you to write for the relative lowering of vapor pressure, this kind of numerical can be asked. Okay. Remember, they will give the pure vapor pressure, then vapor pressure of the solution, and also they will give the W2 and W1 values along with the M value. Next, the boiling point of benzene. So you have to find out for the elevation of boiling point of the benzene is 353.23 Kelvin, and when 1.80 grams of non-volatile solute was dissolved in 90 grams of benzene, the boiling point will be raised to 354.11 Kelvin. Calculate the molar mass of the solute. So you have to write down the equation for boiling point of the solution, that is nothing but an elevation in boiling point colligative property. So since you have to calculate the molar mass of the solute, I will write M. So the formula is Kb into W2 into M1 divided by delta Tb into W1. So for this numerical, the Kb value is given. Kb is equal to 2.53 kg per mole, and also this is the formula that we use to calculate the boiling point of the solution. Okay. So first of all, we have to know what is Kb value. I have written that is 2.53. And what is W2 here? W2 is nothing but a solute. It is 1.80, and W1 is nothing but 90. What is TB here? TB is nothing but change in temperature, that is final minus initial. What is the final which has been raised? It is 354.11 minus 353.23. If you subtract this, you will get 0.88 Kelvin. Okay, just do over the substitution now. It is 2.53 into 1.80 into 1000 divided by, it is 0.88 into 90. Okay, if you do over the simple calculation, you will get the values as 57.5 gram per mole. Okay, this is how, if they ask you to calculate the boiling point of the solution, you have to solve with the raise in boiling point by placing the delta Tb values. Sometimes delta Tb values can be directly given. If they have given the two temperature, keep that in a point, you have to find out the delta Tb, that is the final minus initial. Okay, next. 12.6 grams of non-volatile electrolyte is dissolved in 75 grams of water. Freezing point of the solution was 271.9 Kelvin. If the molar depression constant is 1.86 Kelvin kg per mole, calculate the molar mass of the solute. So freezing point of the water is also given. Okay. Now I'll write the formula, that is molar mass of the solute is nothing but, since it is a freezing point, it is a Kf into W2 into 1000 divided by W1 into delta Tf. Okay. So what is Kf value? That is molar depression constant value is 1.86. Okay. Next, what is the solute gram is 12.6. What is the W1? So W1 is nothing but 75 gram. This is a solid and this is a solvent. Freezing point of the solution is 271.9 Kelvin, and the freezing point of the pure water they are also given. So we have to subtract the delta TF, T minus TF minus TF naught. So here the values is 273.15 minus 271.9 Kelvin. So how much you'll get if you subtract? 1.75 Kelvin. Okay. So now substitute the values. It is 1.86 into 12.6 into 1000 divided by W1 values is 75 into, it is 1.25. Okay, 1.25. You'll get 250 gram per mole. 250 gram per mole. This is how the freezing point, a depression in the freezing point can also be calculated just with looking at the data. Finally, 300 cm cube of an aqueous solution of a protein contains 2.12 grams of a protein, and osmotic pressure of such solution is 300 Kelvin was found to be 3.89 into 10 to the minus 3 bar. Calculate the molar mass of the protein, and or also they have given, correct? So you have to calculate what? Osmotic pressure here. So calculate the molar mass of the protein, okay, because they have given the osmotic pressure. Correct? Yes. So the formula is M into W2 into RT divided by osmotic pressure into volume. We know that what is W2 here? W2 is nothing but a mass of the solute. So the volume is given here. It is 300 centimeter cube. I can write 0.3 meters. And also they have given the R value, that is 0.0823. What is the temperature they have given? 300 Kelvin. And also they have given osmotic pressure of the solution was found to be, how much it is? 3.89 into 10 to the power of minus 3, and calculate the molar mass of the solute. So here W2 values is 2.12. Okay. So it is 2.12 into R is 0.0823. What is the temperature? It is 300 divided by, what is the osmotic pressure? It is 3.89 into 10 to the power of minus 3. What is the volume? 0.3. If you do with a simple calculation, you will get 44.852 gram per mole. 44.852 gram per mole. This is how if the osmotic pressure is given, we can calculate the molar mass of the solute with this equation. Hope you all understood with this numerical. So hope I covered the important questions which will be repeatedly asked from this unit. Hope you all understood. I'll come back with the next unit. Till that, take care, be safe. Thank you.